This lesson is on pictures of data. This is section 2-3 in your textbook. There are many different pictures you can make of data. We're just going to take a look at 4 of them. Let's say that, for example, a researcher or a poster wants to determine how many Democrats, Republicans, and Independents there are in a certain city. Let's say that the city is our city, USA. Let's say that next the researcher goes out and he or she collects the data and summarizes the data using a frequency table. First of all, we would have the party of the individuals. Then we would have the frequency. Now, suppose that the researcher or the poster passes out a survey form to 90 individuals. And they get the survey forms back, they make the tally marks, and they find that they have from Democrats, they have 40 forms, 40 individuals in the sample. 40 of the individuals are Democrats. Republicans, let's say that they also have 40 survey forms that indicate that the individuals are Democrats. And the Independents, they have 10 forms. The researchers or the posters have 10 forms from Independents. Now, the first type of picture we're going to look at is what we call a circle graph. To make a circle graph from a frequency table, you first have to determine the relative frequency of your different categories. If you're dealing with classes, you would determine the relative frequency of each class. If you're dealing with numbers or scores, you would determine the relative frequency of each score. Now, by relative frequency, we mean the frequency of that score or that category compared with the frequency of all the scores or all the categories. In other words, you would have the frequency for that class divided by the total frequency, or what we call the cumulative frequency. Now, this means that in order for us to make a circle graph using this frequency table, we have to add another column to the frequency table. So we make another column here after frequency, and we call that column the relative frequency column. The relative frequency column. This is the frequency of each category relative to the frequencies of all the categories together. For example, for the Democrats, we have 40. That's the frequency for the Democrats. The total frequency, the combined frequency, or the cumulative frequency for all of these different categories is 90. 40 plus 40 plus 10 will give us 90. That's the cumulative frequency or the combined frequency or the total frequency. The relative frequency for the Democrats, since there are 40 of them, would be 40 over 90. 40 over 90. That is the relative frequency for the Democrats. Now, for the other individuals, we have a different relative frequency for some of them. For the Republicans, we have 40 over the total, which is 40 over 90. That's the relative frequency. Now, the next thing we have to do is take these relative frequencies that are written as fractions, and we have to change them into decimals. So we take out our calculators and we divide these numbers that we have here. First, we would have 40 divided by 90. That gives us 0.44 or 44 hundredths. Next, we have the same number, 40 divided by 90. So that will still give us 0.44 or 44 hundredths. And lastly, we have 10 divided by 90, which gives us 0.11 or 11 hundredths. Thus, we have the relative frequencies of the different categories of political parties. Now, the next step in constructing a circle graph is to take each one of those relative frequencies and multiply each one by 360 degrees. Remember that there are 360 degrees in a circle. When we say that the relative frequency here for the Democrats is 44 hundredths, we mean that 44% of the individuals that we surveyed were Democrats. This means that 44% of our circle, 44% of the 360 degrees should be devoted to the Democratic Party. So we make a computation. 44% of 360 degrees. We have 0.44 times 360 degrees. We multiply those two numbers together, and we find that our circle should be about 158.4 degrees for the Democrats. It should be that much for the Democrats. And what we're going to do here is just round this off to the nearest whole number. That would be 158 degrees. That's the portion of the circle that will be devoted to the Democratic Party. That would be 44% of the circle. The relative frequency, or the number of Democrats, is 44%. Of course, these numbers are rounded off. So whenever you round numbers off, you should make a note of that. If you have a table that you're presenting in a study, you will notice here that the numbers here, the percentages do not, or the decimals do not add up to 1, or the percentages do not add up to 100%. And of course, the reason there is that you rounded these decimals to the nearest hundredth. So you should make a note of that at the bottom of your table. Now, next we have to look at the Republicans. For the Republicans, we still have 44% of the circle. The total circle is 360 degrees. That gives us the same number that we had for the Democrats, 58 degrees. And then we come to the independents. For the independents, we would have 11/100 times 360 degrees. We work this out on the calculator, and we get 39.6, which we round off to 40 degrees. Now, these are the numbers that we use to draw the different sections of the circle. Now, once we have done this, we take an object that will allow us to draw a nice round circle. We might decide to use a compass. We might decide to use a top that comes off of a jar. Anything that will allow us to draw a round circle. Of course, the compass would be the best instrument to use to draw a round circle, because you should get a perfectly round circle, and you can draw round circles of different sizes. So we take out a compass, and we draw a nice round circle. So of course I'm not using a compass here, so my circle is not exactly round. But that's the idea. We draw a nice round circle. And then through the center of the circle, we draw a light line with a pencil through the center of the circle. And then we take a protractor. We take a protractor, we put the center of the protractor here, and the edge of the protractor, 0 degrees, we put there. And then we measure from here on the protractor until we get to 158 degrees. And we put a mark. This would be our 158 degrees. So that means that from here to there, from here to there, would be the amount of the circle, 44% of the circle, the amount that we should devote to the Democrats. So once we measure that with the protractor, we can erase these other lines that we have here. And we can enter the name of this section, which is Democratic Party, and we can put in the percentage, 44%. 44% of the individuals in the sample were Democrats. Now we do the same thing for the Republicans. We just extend this line here, extend it back in this direction. We put our protractor here, but this time the protractor is upside down. We have the 0 of the protractor here, and we count across around on the protractor until we get to 158 degrees again, because we said that we would allot 44% of 360 for the Republicans, which came out to be 158 degrees. So we mark that off, and then we draw a line or a segment from the center to that point. And this is the Republican segment of the circle. So we have here the Republicans, 44%. The Republicans, 44%. Now, theoretically, all your percentages should add up to 100%. So really, there's no need to measure off the amount that we have for the independents. So in the last section, all we have to do is just write independents, independent candidates, and write in the percentage, 11%. Now, completes our circular graph. This is one way of picturing data, of summarizing data in a picture so that it's easy to understand. If you look at this circle graph, you'll notice that the percentages here do not add up to 100%. They only add up to 99%. So you need to make a note of that. Under your circular graph, you need to make a note of that. You might say something of this nature. The percentages do not add to 100% due to rounding. You're letting the people know that look at your research study why these percentages do not add up to 100%. It's because we had to round these percents off so that they would be much easier to remember, much easier to understand. So this concludes our discussion of the circle graph.